All right, in the last video, we talked about angle measure in radians as we went around in the unit circle. This time, I'm going to show you why we use the unit circle to figure out trig values. But we're going to actually start off with triangles. I believe that using triangles to learn the unit circle is the best way to do it. Don't just memorize the unit circle, understand the unit circle. And so here's where we're going to start with our triangles. I've got this basic 45, 45, 90 triangle, and I'm going to give it a hypotenuse of 1. Now, because it's 45, 45, that means that these two sides are the same. I want you to figure out what are these two sides. Take a moment and figure it out if you want. All right, if you pause the video, we're going to go ahead and get started now. We're going to go ahead and say that this is a right angle, and that this is x and this is x right here, which means if we use the Pythagorean theorem, we get x squared plus x squared equals 1, or 2x squared is equal to 1. Keep solving for this thing. We're going to divide both sides by 2, and we get x squared equals 1/2, and then square root both sides, and we get x is equal to the square root of 1/2, which equals square root of 1 over the square root of 2, which equals 1 over the square root of 2. And we can rationalize the denominator here. So if we rationalize the denominator, we've got 1 over root 2, multiply it by root 2 over root 2, and this gives me root 2 over just 2. So that's it, rationalized there. That is what the side lengths are to this triangle. In fact, I'm going to go ahead and write it on this triangle because we're going to use that in the unit circle. Bam, there we go. And that sets up this so I can apply it to the unit circle here in a moment. Let's look at the next triangle I want you to know. All right, right there it is. And so on this one, we can't use that little trick where you say x and x right here and say x squared plus x squared equals 1, because these are not the same length like they were on our 45, 45, 90 triangle. This instead is our 30, 60, 90 triangle, and it's a special one also. Now I will give you this though, this side length right here is 1/2. And so we want to know what is this length right here. So once again, we can call that x. You can pause the video if you want, use the Pythagorean theorem and figure it out. All right, back from your pause, we're going to say x squared plus 1/2 quantity squared here is equal to 1 squared, and solve for x. Well, 1/2 squared is 1/4, and 1 squared is 1. I'm going to subtract 1/4 from both sides and get x squared equals 3 over 4. Square root both sides, and you get x equals the square root of 3/4, which equals square root of 3 over square root of 4, which equals the square root of 3 over 2. That is their length for this third side here, the value of x, square root of 3 over 2. Now let's take and look at this on the unit circle. Now, if you've not watched my video on how to come up with the radian measures going around the unit circle, go ahead and watch that now so you're a little bit familiar with it. I usually in my class go over this over and over and over again with students. Each class that we have, we draw the unit circle on the board, we go around the circle marking those angles, and then we begin the lesson. So that way they get used to it. I'm going to spare you of that today so you don't have to keep doing it in the videos. You have that option to go back and watch it yourself. So looking at the unit circle here, this is it marked out with the angles already drawn. I messed up there and had to recorrect it because I forgot to reduce. So it's 5 pi over 3 right down there. And what I'm going to do with this is start to place these triangles on here. But before I do that, I want to make a couple of points here. One, if we pretend like this is the origin, okay, and I'm giving you x and y coordinates, the unit circle by definition means that we have a radius of 1. So the radius going all the way around the circle is length 1. From here to here, here to here, downwards, it's length 1 everywhere. So if I write out some ordered pairs here, I get 1, 0 for right here. Because that's, if you're marking a location on a Cartesian plane, you would say I go over 1, up none. Right here at the very top at pi over 2, this would be at 0, 1. At pi, we would be at, well, this is on the x-axis going -1 and then up none, so -1, 0 there. And down below at 3 pi over 2, we'd be at 0, -1. So that's what that looks like. Now, where are these other points? So that's when we get into the triangles that we drew. I'm going to start with the 45, 45, 90, or this is at the pi over 4 angle here. Let's zoom in on that. So what this is saying is, notice that we are going over square root of 2 over 2, and then we're going up square root of 2 over 2. So at pi over 4, the location here is square root of 2 over 2, comma, square root of 2 over 2. That's our x and our y coordinates there. If I look on the other side at that other 45-degree angle at 3 pi over 4, it's right here. And notice we go over square root of 2 over 2 and then up square root of 2 over 2. Now, the only difference here is we're going in the negative direction for x. So I need to put this down as negative root 2 over 2 for my x value, and then positive root 2 over 2 for my y value there. And so at 3 pi over 4, we're at negative root 2 over 2, comma, root 2 over 2. Now, these do have meanings. I'm not just randomly going around and having fun marking these x and y coordinates. They will have significant meaning once we dig a little bit deeper into this. What I want you to do right now is to be able to go around the unit circle, label the angles, and label those x and y values. So that takes care of these two 45s up top. If I look down below here at the bottom of the unit circle, I can actually flip these triangles around and make them look like this right here. So lining this one up and lining this one up, I've got 5 pi over 4 right here. This is at negative root 2 over 2, negative root 2 over 2. So that's right there. And then this one right here in quadrant 4, you're going to have a positive root 2 over 2 and then a negative root 2 over 2 for your y coordinate. So that takes care of all the 45-degree angles there. The next thing we're going to look at are these 30, 60, 90s going on in here. Now, if you forget what's going on with this stuff as far as the y value goes, you can always just think about it. If this is from 0 to 1 right here, if you were to trace this pi over 2 angle back to the y coordinate, just to guess where the y value is at that location, it's about halfway up the y-axis. So you could guess that the y coordinate here is going to be 1/2. Actually, I'm going to write it in here so we can see a little bit better. You could almost guess that that's going to be 1/2. But if you're not sure, you could always draw out those triangles like we did at the beginning of the video and calculate it out. My goal is for you by the end of my class is for you to have those two triangles memorized. It doesn't take much to memorize them. And then when you do the unit circle, to visualize those triangles as you go around. So if I place this triangle right here, notice I go up 1/2. The radius is 1. That's why our hypotenuse is 1. And then the x coordinate here is going to be square root of 3 over 2. Now, if you get a calculator and actually punch in square root of 3 over 2, let's see what that looks like. Let's see if I've got square root of 3, hit enter, and then divide by 2, you get 0.866, or close to 9/10. And if you look at this, this is from 0 to 1. We're about 9/10 of the way here. And so this right here is square root of 3 over 2. This triangle we can flip around and make it look like this one right here. Notice I'm just taking this thing and spinning it around to right there. Same side lengths, but now it's standing up on its smaller edge there. And notice the x coordinate is 1/2 because we're about halfway between, well, we are halfway between 0 and 1 on the x-axis. So the x coordinate here is 1/2, and this time the y coordinate is going up about 0.86 of the way to 1. So this is going to be root 3 over 2 right here. So that takes care of quadrant 1. We've got ordered pairs 1, 0, square root of 3 over 2, 1/2, square root of 2 over 2, square root of 2 over 2, 1/2 root 3 over 2, and 0, 1. That's your quadrant 1. We're going to go through each quadrant here that's remaining and quickly put those out. So if I look at this one right here, notice we go -1/2, comma, positive root 3 over 2. If I look at this one right here, we're going negative root 3 over 2, and then positive 1/2. And then down below, we're going to put one in right here. We've got negative root 3 over 2. This is at 7 pi over 6. Negative root 3 over 2. And then we're going to come down negative 1/2. Notice all of our values down here are negative. Right here, we're going to go and put our triangle in like this. And so you should start to see, once you realize where 4 pi over 3 is on the unit circle, you can start to visualize this triangle right here and say, oh, I go negative 1/2 for my x value, and then I go negative root 3 over 2 for my y value. So negative 1/2 comma negative root 3 over 2. And then lastly, we've got quadrant 4 here. So let's see, if I put in the triangle right here, I got positive 1/2 for my x value. So positive 1/2. And then for my y value, I'm going negative root 3 over 2. And then lastly, we got one more right here. Place it in like this. I'm going positive root 3 over 2, comma, negative 1/2. And so this gives me the complete unit circle here with the ordered pairs. Now these have meaning, and it's related to our sine and cosine trig functions, which we will talk about why that works the way it does. But it does have meaning. What I want you to do now is take and practice these angles and radians, and then practice writing out the ordered pairs. What I've got here is, I'll leave a link for this in the description. This is basically, a lot of times I will give a quiz, or I'll give these out as practice sheets. There are 2 per side here, and I print them off front to back, so students have 4 copies of these. If you're in my class, you can get extra copies, as many extra copies as you want. If you're not, or if you're at home watching and you don't have this, you want to print it out, I'll put a link in the description. But basically, the way I've set this up is that you've got the whole unit circle here. You're going to put those ordered pairs going around the circle. I would have written on this, but I feel like if I wrote in, I don't know, you wouldn't be able to see something like square root of 3 over 2, comma 1/2. I think it smudges together with the markers, and you can't see it as easily as this larger one that I put out here. But you can print this out, go through and practice the ordered pairs, write the radian measure on the line here. So this would be 0, or you could say 2 pi as well. And then you've got pi over 2 right here. You go around and write the radian measure on this blank. Now it also says to write the trig value, the tangent value, in the box. We haven't learned that yet, so don't worry about that, and don't worry about sine and cosine right now. But print these off and give them a try. Make sure you can go around and write down all the angles. Make sure you can go around and write down all of the ordered pairs. And if you can do that, you're well on your way of learning the unit circle really well. But there's still some more to it that we need to go through. So give that a practice, and then we will talk about what those ordered pairs mean in the next video. Thanks for watching, and I hope you have a great day.